Tell everyone to take their Welcome, everyone. We will be getting started in just a couple of minutes, so everyone just settle on in. And yeah, thanks for coming. Welcome, everyone. Thanks for coming to the staking gathering. I just want to kick things off and just say a quick thank you to the sponsors, all the volunteers, and the Ethereum Foundation, of course, for helping us coordinate all this. It's an absolutely beautiful venue, and all the helpers and everything. It's been amazing. We have a jam-packed schedule, tons of stuff coming up. If anybody wants to know the agenda, there's one right out front. And then there's the signs all over for Wi-Fi. Bathrooms are kind of in between the floors, so I'm sure you guys will be able to find it. I'm excited to introduce Elon from ssv.network, who's going to be kicking things off. And yeah, without further ado, come on up, Elon.
Hey, everyone. Can you guys can hear me well, right? Perfect. So thanks for coming. Happy to kick off the event as well. And so today I wanted to present ssv.network. It's a decentralized infrastructure for Ethereum staking. I'm leading this project, and there's a bunch of people involved, and I'm very excited to kind of present it to you guys. But I think in order to understand exactly what we're doing, it's also important to talk about kind of the current state of Ethereum staking. I guess most of you guys are familiar with staking, right? Perfect. Awesome. Good vibes. So Ethereum staking started out live about 16 months ago, December 2020. We already have 360,000 validators running on the network, which is pretty amazing. It comes out to about 11.5 million ETH. I don't know what's the percentage of the circulating supply of ETH. You can do the math yourself, but it's pretty significant, and that's before the merge, before withdrawals are enabled, and so on and so forth. We're talking about $35 billion at stake, and the current kind of reward rate you'll get is about 4.5%, which is pretty significant. And really the next big milestone is going to be the merge. The merge is really when this whole POS kind of test is actually kicking into gear and actually starting to validate transactions, because as of now the Beacon chain doesn't really process any transactions. And so the merge is that event in which the old Ethereum chain is going to literally merge with the new Ethereum chain. Proof of work is going to terminate, and everything will move to proof of stake. That is, validators will, for the first time, will start validating actual transactions, earning actual transaction fees. And of course, you'll see more rewards as a result of it. And it will open up new things like MEV for validators and so on. We won't get into more details about that, but the merge is the big event everyone is talking about. And hopefully it's going to happen in Q3. That's the kind of the current guesstimation, but it really is the big thing. But it also presents a lot of challenges. Some of those challenges are challenges today and will get aggravated as we go along. Some of them are new. Slashing challenges, everyone knows that, right? If you go do something against the protocol, you get slashed. It's a big penalty, and so on and so forth. We see the emergence of centralization or forces as drive to centralization, which is something everyone, I guess, is concerned about. Centralization, or a subset of that problem, is also client diversity. Basically, the idea that there's not going to be a single point of failure that can take down Ethereum. And that's a big challenge of its own. And of course, staking in general has a very high cost for development and maintenance. And we'll see in a second why. But that a lot of that also turns into challenges in development and building infrastructure, and of course hinders innovation. The bottom line is Ethereum staking is hard. I haven't mentioned your keys actually need to be 24/7 online, which is another big thing. But in general, Ethereum staking is hard. And it gets even harder now because almost every staking provider also developed their own infrastructure, which, again, is very, very challenging. If we need to break down how it actually looks like, this is the basic infrastructural scheme of almost every staking service out there, from Coinbase all the way to the startup which have one validator online. This is the basic way people set up their infrastructure, and the reason why is actually derived from the very Ethereum spec, or the very Ethereum protocol. And so in the middle, you have this thing called validator client. It's just basically a piece of software. That piece of software has a bunch of keys. Each key, each validator box you see here is a 32 ETH validator on Ethereum. And that software only coordinates those validators into executing the tasks which they are assigned to periodically every 6 minutes or so. And that's a very basic infrastructure. Now you can see right away that this infrastructure has a flaw in it. It's literally a single point of failure. That big thing in the middle is literally a single point of failure, and that creates a lot of challenges and a lot of risks. So validator clients can only run a unique set of keys. If you do run multiple validator clients with a non-unique set of keys, you'll risk slashing, or almost 100% guaranteed to get slashed. And so stuff like robustness through backup or through redundancy is very difficult to build into infrastructure on Ethereum. You have to keep up to date all of the past signatures you actually signed with your validator key into a database called a slashing database. And if you lose that database, if you don't back it up, if you don't restore it correctly, you have the risk of getting slashed. Of course, your keys must be 24/7 online, which is a big thing. And because the infrastructure itself is not really reusable, the development costs are pretty significant. That is, if you want to build a mom-and-pop shop for staking service, it's going to cost you a lot of money, a lot of resources, and a lot of knowledge and experience in order to actually do that. The bottom line is that everything we've learned in general in software development, but specifically in crypto and in blockchain, the way you manage keys, the way you store them, and so on, doesn't really apply for staking because of the unique characteristics of how staking on Ethereum works. And that's really the main challenge we're facing. It leads to centralization. It leads to an ever-increasing systemic risk on Ethereum itself. There's a built-in mechanism in Ethereum that the more people get slashed in a single point in time, the bigger the penalties are. And in general, centralization is a risk we all carry. And so if we have a very centralized network, then we all carry that risk with us, which is significant. It's very costly. And I think that the last part is that because this infrastructure is not reusable, it also hinders innovation, because when cost of innovation is very high, it's very hard to innovate. And so one of the cool things happening in the tech world, and specifically in the blockchain space, is that we've managed to create those components which everyone can use. A lot of those components are the blockchains themselves, which really lower the cost of development. And you can see that even in the number of employees per blockchain company versus even Web 2 companies. It's pretty amazing. It's an order of magnitude less. And so with all that presentation, that's really where SSV comes to play. SSV is a protocol. It's a decentralized infrastructure for Ethereum, which tries to solve all of those issues we've kind of listed today. Well, how it works? Well, it first of all doesn't use one validator client, or if we need to generalize, not a single staking service or staking operator to run validators. It uses multiple of them, and each one of them doesn't hold the full key. So there's no single point of failure. We use threshold signatures and BFT consensus protocols to coordinate and execute, which builds in fault tolerance within the protocol. And the cool thing about it is, if you build it right, it's a reusable infrastructure. That is, anyone can use it in a permissionless way and just build the application and not the infrastructure beneath it, but still have a really solid decentralized infrastructure. And it looks something like this. And right away you can see the kind of the central part or the center of it. Instead of having a single point of failure, all of a sudden you can use multiple nodes, in our case, that actually execute and run those validators. So if one of them, for example, fails, if one of them gets compromised, nothing happens, because they need to work as a group in order to actually produce a valid signature. And so if one of them fails because they get hacked, for example, the rest of them just continue to work, and nothing happens. The validator is not compromised, the validator doesn't lose any rewards, and so on. And that's really the heart of it. Instead of having a single point of failure, instead of having a single point where it needs to run everything, all of a sudden you have a multiple of them, and that really brings out a lot of characteristics. And this is how it kind of works internally. So every validator, periodically, every 6 minutes or so, has a new thing to do on the Beacon chain. That thing can be an attestation, that thing can be proposing a block, whatever that thing is. And all of those 4, 7, 10, whatever the amount of operators you choose, once that new thing comes in, they select a leader in a deterministic way. That leader proposes what they need to do. For example, sign an attestation. If they agree through some kind of a consensus protocol, which is the far right, the top right, circle, they need to decide on how they want to approach it, right? What they need to sign, and that's where fault tolerance kicks in. That's where the robustness, and that's where the power of SSV comes from. And once they decide that actually each one of them locally produces a partial signature, they reconstruct the full signature, and all of a sudden you have a full attestation, block proposal, whatever the task was. And that also means that none of them actually hold the full key, right? So they need each other in order to operate. And those node operators, those staking services can be completely independent. They don't need to know each other. They don't need to trust each other. They just talk through a consensus protocol. And the benefits are pretty significant. So for the first thing is, you don't need to have your key online anymore. You can put it in cold storage. You can keep it safe, like keys should be stored, because each one of those operators only needs a share. It doesn't need the full key. We use threshold signatures for security. None of them can be compromised and compromise the whole validator. There's no single point of failure. It's decentralized and fault tolerance. And it's a reusable infrastructure. You can keep using the same operators, the same network, the same setups over and over again, and the cost of integrating SSV is nothing. It's literally a smart contract call. And that's pretty big news. And the cool thing is, it's not science fiction. It's been running in testnet for 12 months. We have a really, really big testnet we've been running, and actually another testnet coming up in a month or so. And so it actually works. This thing works. We have close to 3,000 operators on the network. Out of those, close to 100 are verified operators. That is, verified means that they are real staking services. Some of them are the biggest in the industry, running a testnet SSV node. And you can choose them today in a click of a mouse. And that's really where we're at, and really we're really at the kind of the final steps before we can be mainnet ready and launch this thing. And so kind of I wanted to show you how it looks like from a really, really simple use case. A solo staker coming with a validator key and wants to run that validator on the SSV network instead of running their own infrastructure, or instead of choosing a centralized service provider. And so this is how it looks like. We've developed a cool web app. It's really, really simple. You click import validator. You put in your validator file, a simple JSON file. If you have a password, you put in the password. And this is the cool part. You have a huge list of operators, and some of them you recognize, some of them you don't see here, but they exist there. And you just choose them, literally choose them. And once you do that, it's a matter of a simple Ethereum transaction, and that's it. Your validator all of a sudden runs in a decentralized way on SSV. You don't need to run any infrastructure. And of course, this flow is a very simplistic one. It's for solo stakers. But you can imagine how other types of staking services can use that via CLI, via smart contracts, via some automated code, and so on and so forth. And I definitely encourage you guys to go and check it out. It's really, really simple. There's thousands and thousands of validators, and people already did that. And so please check it out. Just go to ssv.network. And so before we finish, I really wanted to talk about what you can do with it, right? Because it's infrastructure. So infrastructure is meant to be used somehow. And I brought a few use cases, but of course there's a bunch of use cases. And the important thing to realize is that once you open up infrastructure in a reusable way, innovation can happen. And so the obvious kind of choice is, solo staking like we just saw. And of course you can do staking pools, right? You can have decentralized staking pool with liquidity token and so on. Use SSV as their backend, basically. You can have DeFi protocols, which hold together today a ton of ETH, and that ETH will eventually find its way into staking, because staking on Ethereum is the de facto interest rate, reference interest rate for standing still Ethereum. We're talking about DAO treasuries, which will stake eventually, and that's really a cool use case, because if you think about it, a DAO is an entity living on the blockchain. And the idea of a DAO actually helping secure the very infrastructure, the very blockchain it lives on, it's pretty wild and it's pretty crazy and it's pretty awesome. And of course, institutional staking together, just using a better infrastructure, more decentralized, lowering the risk, and so on and so forth. And so those are kind of the typical use cases you can find out. And we actually have a dedicated presentation tomorrow at 9 a.m. With Meritis, which sits right here. He will go through the use cases and kind of dig into how it will look like. But I definitely encourage you to try it out. And also, I wanted to kind of openly call developers to come and check us out. We have a big grant program for developers to come in, submit an application, and actually get pretty significant grants to build on top of SSV. And of course, the incentivized testnet, the V2 incentivized testnet starting in June, to incentivize basically people to come and interact with the network. And so if you kind of fall into those groups, please reach out, please check us out, and thank you. I guess we have like a few minutes for Q&A, maybe? Yeah, perfect. Anyone? Nope. Yeah?
Yeah. I'm actually part of this.
Yeah.
So, whatever. You said people should go to testnet, try this out. How do they get girly ETH to actually try it?
So it's a really pain. It's a real pain. I know it's probably the most scarce commodity in the world right now. We have a bot working, and it puts out, I think, about 100 validators a day, depending on how much girly ETH we have. So you can reach out there. In general, there's a proposal coming up to print a limitless amount of girly ETH, so hopefully this problem will get solved. But yeah, you can contact us, and if we have some, and we usually have, we'll be more than happy to help. Yeah.
That's your Discord, right?
Yeah, on Discord. Yeah.
Right. You mentioned briefly 4, 7, 10 or whatever. Can you speak a little to how that works?
Yeah, so in general, in order for SSV to be fault tolerant, which means that there's a certain amount of those nodes we saw that can be faulty. And by faulty, we mean literally faulty, or that also can be dishonest, like literally a node that got hacked and maybe somebody's trying to play with it and try to attack the network. And so usually well, I get maybe too technical right now, but in BFT protocols, usually you're talking about up to a third of those nodes being faulty. And so in general, if you choose the amount of operators you want to run on SSV, in order for them to be fault tolerant, which you want them to be, you need to choose 3F plus 1 operators. And so an F can vary, right? So if F equals 1, 4 operators, right? If F equals 2, 7 operators, and so on and so forth. I think above 10 and 13 operators, that's like too much, but anywhere between 4 and 13, I think it's pretty logical to do. And so yeah, you can choose, and of course, the more operators you have, the more fault tolerant they are, and so on.
How many can be done?
Like theoretically, you have BFT protocols with up to 100. Cosmos, I think, has even more than 100.
Say I have 4 or I have 7. How many of those are?
Oh, so in 4 you have 1 which can be faulty, with 7 2, and so on.
Okay.
Yep.
Do you have any plans in the future to natively, like through SSV, support a staking pool that would enable users to deposit less than 32 weeks, or is that not on?
No. SSV is very focused on being infrastructure. When we started this whole thing, we thought about doing SSV staking pools, SSV, a few different ideas. We really like the idea of being infrastructure and people building on top of SSV, so we don't have any plans on building the actual app, which, except what you saw here, but that's really for testing. There's nothing we do in terms of an app or an end user staking service. That's why we encourage developers to come and build their staking services and use SSV as infrastructure. Yep.
Interesting with the DAO integration. Maybe tomorrow we'll get more info, but
Yeah, I mean. Yeah, so first of all, be more than happy to talk after the presentation as well. What I like about DAOs in particular is that, first of all, there's DAOs holding a lot of ETH today. And also there's DAOs controlling protocols which all hold a lot of ETH. I really like the idea, and DAOs have a very high tolerance towards Ethereum price fluctuations because they're thinking long term. And so couple that with the idea of DAOs as an organism living on the blockchain and then helping secure the blockchain, I think there's a lot of interesting things to do there. In my opinion, you'll see more and more DAOs putting ETH into staking, earning their rewards, and then those rewards, depending on how large your ETH pool is, they might be able to even cover some or all of their expenses throughout the year. And so if that happens, that's a very interesting mechanism for DAOs and DAO treasuries in particular. And yeah, we'll talk about it more in the next tomorrow in the next presentation. Yeah.
I have another question. Like I understood, you open your web page and then you insert with drag and drop your private key and put in your password, and then it gets shared on the machines that you can choose. But this moment of putting it on this web page, to drag and drop and insert your password, it seems for me kind of...
Oh, it's very insecure. That's why I said it's for testing. So this whole process of using a private key, splitting into shares, can happen anywhere. It's not an online process. You can do it in a box, disconnected from the world, and so on and so forth. And also you can use more advanced key management schemes like DKG and so on. And so this is very much for testing. I wouldn't recommend anyone putting a private key online. But for the purposes of a testing, it's very easy to do. And so yeah, definitely when you're building something on SSV, key management is definitely a part of it, yeah. Any other questions? If not, thank you, everyone. Thank you for listening, and please reach out.
So we're going to have a break here until 2 p.m. when the quiz show starts. So you have a good amount of time now, and please come back at 2.
There's Phil. Yep. Did you want to introduce us, or did you just want us to go? Okay. Yeah, that's what we're waiting a little bit. Don't worry, this is a chance to flex your knowledge. Come on, y'all. That's right. Yeah, there we go. More the merrier, everyone. James Charles. Interesting combination there. Come on in, take a seat, gentlemen. Get joined up. I do think it times you out if we wait too long, so if your name happens to go away, just rejoin. It shouldn't be that much of an issue, and I do apologize.
Another minute?
1 minute.
All right.
We're going to get started here in 1 minute, y'all. And again, if you have to-
Kahoot.it. Enter in 7372108.
If you happen to drop out of the list, we do apologize. It'll time you out after a little bit of time. Just rejoin. We're going to try to make sure everybody's in before we start.
Play along. The questions are mostly Ethereum related, mostly staking related, but also some fun stuff.
You'll be surprised at some of the questions. All right, we're about to.
All right.
Sir?
Another 30 seconds. Last chance.
Yep, last chance to get in. If
Make
you
sure
fall
you're
out
in.
again, just rejoin. We do apologize for that.
Play along. If you're on the live stream too, you can still play.
Yep, if you're on the live stream, you can still play. The questions and answers will appear on the device that you're using, so you don't necessarily have to look at the screen. Especially if you're at home, you can look at your device. It'll show you everything that you need to know in real time, so there's no stream delay for you. Okay, everybody, I guess that we're going to go ahead and get started. Welcome to the eStaker Gathering Quiz Show. We're so happy that you all are here. Excited to see you come in and flex your knowledge on Ethereum and other things that we have in this quiz. This quiz was created by Nolan. He's going to talk a little bit about it, his little thought process and everything. So go ahead, Nolan.
All right, so we've done a few of these quiz shows before, and there's always one or two really smart people that get like 48 or 49 out of 50 questions correct. So I tried to make the questions, I tried to throw in a few really hard ones. So I think we're going to really separate the big brains and the enthusiasts. But anyways, this should be really fun. It's mostly Ethereum stuff, lots of staking stuff, and then also just some random questions just for fun.
Everybody in the audience good? Are you in?
It's 32 questions.
Yeah, it's 32 questions. Yep, you need to turn on your mic, Thorsten.
All right.
How about now?
Yep,
Perfect.
I'm going to let everybody kind of take 1 second to connect because it will drop you out if we wait too long. So I don't want anybody to be left behind.
We got
Are we all
31.
good? No? You need to get in?
Yeah, but it says the pin is not, doesn't recognize the pin.
Doesn't recognize the pin. 7372108. Yep.
Is that you, Jimmy?
Oh, somebody dropped out. I want to make sure you're still here.
I think they can join after we start, too.
That's good. I don't want to miss a question.
So we're streaming this, right? Anybody can join this?
Yes.
I believe so.
Yes, I do believe if you are watching on the live stream, you can join as well. The questions and answers will go to your device, so you don't have to worry about any stream delay. Just make sure to keep your eyes on your device. All right. I think we're good now? Yeah? All right.
Yeah,
So let's go ahead and
36.
get
Let's
started,
go.
everyone. Of course, welcome to the Devconnect Amsterdam Staking Gathering Quiz Show, everybody. All right. Where was Mr. F? Here, there, present, or absent? You got 23 seconds.
That's a good one. Bonus points if you know who Mr. F is and when he first appeared on the beacon chain.
All right, this is going to tell us a lot, I think.
Who are the OGs?
The answer's
There we
here.
go. Most people knew.
You want to explain why?
The very first block proposed on the beacon chain had the graffiti, Mr. F was here.
That's right. All right, next question, everyone. Or actually, yeah, let's see.
Nope. Buddha looking good.
You are going to win.
All right, everyone, next question. What is EIP 3675? Is it an upgrade consensus to proof of stake, base fee opcode, difficulty bomb delay to June 2022, or Serenity Phase 0? Only 10 seconds on this one.
I do not memorize EIPs. I would fail this.
Those are tough. I agree.
This is an important one.
I'm sure it is.
So, kind of the reason why we're all here, right? Proof of stake.
That's the merge. There you go.
The merge win. All right. Who's going up?
Big shake
Oh,
up.
butter, you god.
See, that's going to what separate the big brains from the not so big brains, right? Okay, everybody, let's go on to the next question. What was the name of the merge testnet? We have Altona, Serenity, Kintsugi, and Altair. Which one is it? Definitely not the one we have right now, the one that came before, if you would know that. Of course, it's Kintsugi. Looks like pretty much everybody got that one. Pretty good. And of course, if you were on there, you got a POAP. I hope there's some people in this room that were able to get that POAP.
POAPs are the reason we all stake. That's it right there.
Yep. Still up top. Top two didn't move. All right. Next question, everyone. What is Matic's proof of stake chain ID? Is it 10, 42, 161, 0x64, or 137? Trust me, I didn't know this one either when I took the quiz, so it is okay. We're all ETH maxis here, right? So.
I actually think I know that, and that's sad.
So it's 137.
Hey, yeah.
Most people actually got that. That's very impressive.
Good work, everyone.
All right, let's see what's going on with the scores. Oh, the whole board just changed. All right, everybody. Let's move on to the next question. All right, what do violations in Plasma have in common? Is it validity proofs, data stored on-chain, data stored off-chain, or they are the same thing?
Okay, I promise that's one of the hardest questions.
That's a hard question.
I also did not know what this was at all, so.
So those, can we give a hint that those have
well, there's only 1 second, so.
Even still, majority of people knew. Okay, very smart
nice.
crowd.
It's good.
Very smart crowd.
All
nice, Michael.
There you go.
Moving up, like the Jeffersons. All right, the Beacon Chain Sync Committee continually blanks for each new slot in the Beacon Chain. They sign block headers, propose blocks, orders transactions, or pays rewards to proposers. Again, the Beacon Chain Sync Committee continually does this for each new slot in the Beacon Chain.
Nice work,
Yeah, that's
everyone.
pretty good.
Nice
Most
work.
people. It's a good thing that most people are going to know that. All right. How's the score changed now? This is like the funnest part to me. Like, yes, who got the question right or wrong, right? Who got it in faster? It's like this whole row is just like competing against each other. Okay, next question, everyone. If you are eligible to get the Lodestar Medallia POAP, you are a legend, a cheater, a client developer, or very lucky.
Who was there? Show of hands.
Yeah, show of hands. Who was
was
there?
on the dash?
So unfortunately, it's not that you're a legend. Do you want to explain why, Nolan?
Throughout the whole Medasha testnet period where we were giving away the POAPs, Lodestar did not have the ability to propose a block. So only people that cheated and lied about what client they were running counted. So we didn't give out the POAP. Lodestar later fixed it, though.
So if you have that...
Shout out to ChainSafe.
Cheater. Ooh. James going up top. First time. All right, everyone. What is an Uncle Bandit? Is it an MEV from a transaction not originally in the mempool? Selfish mining optimizing for uncles? Intentionally uncling a block to revert a transaction, or a fake thing Lamboshi made up? God, you put too much words in that one, man. That's like by the time I read it all, it was already over.
Who are the MEV experts?
Buddha's over here like, yes, I got it.
Phil, did you get it?
Let's see if that puts you on top. It did!
Phil got it.
Oh, man. James, what happened? Oh, no. Well, at least you're still in fourth place, so you got a little bit going for you. All right, everyone, next question. What is Justin Sun's most recent job? Is it a CEO, a VC, a diplomat, or a developer?
This was like a big 6 hours on crypto Twitter. Everyone was talking about this.
A diplomat.
Of course it's the weird one.
You want to explain the drama?
Not really.
Not really? All right, I got you. Let's go on with this. Buddha kept it. He kept it. You messed that one up? Sorry, man. Question 10. What did early members of the Ethereum Foundation call their house in Zug? Was it the Hacker House, the EFHQ, the landing pad, or the spaceship? Again, what did the early members of the Ethereum Foundation call their house in Zug? Hopefully I said that correctly.
If you've read The Infinite Machine, you would know.
Zoop? Is it like Zoop?
I think it's Zug.
Of course, they called it the spaceship.
Nice.
Yeah, you did press it pretty quick because you stayed up top, didn't you? Exactly right. Just pick one. Hopefully it's right. Okay. How much will the merge increase Ethereum's transaction throughput? Is there going to be no change? Is it a 1.1x, a 64x, or a 64,000x? 9 seconds. 8, 7, no pressure. 6, 5. Hey, pretty good. Do you want to explain why?
In the beacon chain, the slots are all 12 seconds each, whereas in proof of work, it's normally like 13 and a half to 14-ish seconds each. So there's a very slight increase in throughput.
Super
Which
small.
you will not feel, and your gas will not go down.
But technically, it's there.
Technically, it's there.
10. Only 13 got that one. Let's see. Did that change things? It sure did. Buddha, what happened? Got overtaken by 2 people. Well, he got the question right, so obviously you would have gotten it right too. All right. How many Ethereum CL clients had a functional remote signer at the launch of the beacon chain? Was it 1, 2, 3, or 4? And again, how many Ethereum consensus layer clients had a functional remote signer at the launch of the beacon chain? 1, 2, 3, or 4?
This was also a big deal on crypto Twitter for 6 hours.
For about 6 hours.
So it was 2. And they were?
Prism and Teku.
Prism and Teku. And one just like everybody wants to use it, right? Okay. Wow, no change except for the top. Our top players are kind of slacking on that one, huh? All right, moving on. Question 13. When was Amsterdam made the capital city of the Netherlands? Little off topic on this one for Ethereum, but was it 2007, 1894, 1983, or technically it isn't? Again, is that 2007, 1894, 1983, or technically it's not? Only 4 people.
Oh, no.
Oh, no. You weren't expecting Amsterdam knowledge in this, were you? I bet the Dutch people got that right. How much does that change things on our board?
Oh, not too much, not too much.
The girls is the highest climber, up 6 places. Congrats on that one. On average, how many Ethereum blocks are uncle? Is it 1 in 3, 1 in 16, 1 in 184, or 1 in 4, 56?
I want to know whether you knew that answer or you had to look that up.
Looking at the uncle rate's a good thing to know for like gas limit increase. So it's kind of yeah.
It's 1 in 16. Do you want to explain what an uncled block would be?
It's a block that's otherwise valid but doesn't get included into the chain because of network latency and things of that nature.
So we're at 1 in 16 on average?
Yes.
And I think we're supposed to call them OMRs now. Is that right?
Oh, really?
I think so. I'm not sure.
Okay.
Congrats, Jimmy, hitting 5 answers straight. Who's Jimmy? You want to raise your hand for me? Congrats, man. All right, guys, move it on. Which of these does not affect the beacon chain attestation reward? Is it a Casper FFG source vote, a Casper FFG target vote, an LMD ghost head vote, or a Casper exclusion vote? This one's kind of hard. I think somebody in this audience might be able to get it kind of easy. And this I had no idea. This is like foreign words to me whenever I first saw it. I was like, what?
Yeah, it wasn't as hard as it sounds.
Yeah.
I just put a lot of jargon into the question.
Yeah, so I was like, what is this saying to me right now?
It sounds like English words, but it makes no sense.
Yeah. Yes. Buddha back on top. Congrats, the girls. Halfway through, how old does an attestation need to be considered by the HLMD ghost fork choice rule? Is it 1 slot exactly, 0 slots exactly, at least 1 slot, or it's from the previous epoch? Again, how old does an attestation need to be considered by the HLMD ghost fork choice rule?
I don't think he was kidding about coming up with hard questions.
Ooh.
You gotta be pretty deep in the protocol.
It's not so bad. Most people knew.
Yeah, at least one.
It's again, I just put a bunch of jargon.
Yeah.
Yeah, he put a bunch of jargon, so I had to read faster. Had to spit it all out in time. Not much change at the top. Moving on. How many validators can be voluntarily exited from the beacon chain per day? Is it 4, 5, 900, or 1,125?
And
again,
this answer
this
changes.
is today.
As of today.
As of today. So that's again exiting from the beacon chain.
So not as of 3 months ago.
Ooh.
Nice work.
Yeah.
Do.
Go ahead, Nolan. Explain. Why is that the case?
Well, it used to be 4 validators per epoch, but we hit a certain threshold of validators, and now it's 5 per epoch.
And so that's 1125 a day. So 900 a day was correct not so long ago.
But we just recently hit the 1125 number.
And 1125 won't be correct in a little while.
Yep.
Because there'll be more.
Still up top. If there are 327,675 active validators, how many validators can be added over the next 3 epochs? Is it 12, 13, 14, or 15?
I apologize for this one. It was cruel and unusual.
It is kind of cruel and unusual.
That is cruel and that really is cruel.
Requires some knowledge of thresholds and math. All right, but it's 13. It's 13.
Yeah, sorry about that one, guys. It's,
Yeah.
No, it's 13. Because the threshold is 680, so it'd be an epoch of 4, an epoch of 4, then an epoch of 5.
Oh my God. Yeah.
You got to do the math.
I'm sorry,
on that
it gets
one.
better. That's the worst
I'm
one
not sure
by
an
far.
apology is sufficient. I
That's
think
the
at
hardest
least
one by far.
I suffered through this
Wow.
POAP is necessary.
The top didn't get it, but Dinomaster, who's Dinomaster? Yeah, brother.
Yeah,
Good job.
man.
4 spots, man. Highest climber. Good job. All right, number 19. How many red light districts does Amsterdam have? Is it 11, 2, 3, or 4?
Oh my God.
Like how it's just 11 instead of 1.
This one, thank you to Patricio Werthalter for this question.
Yes, it's like he just had
Very
it off the
well
top of his
written.
head. You know. So
It's 3.
It's 3.
Ooh, Anon.
Yes, welcome
Hitting the
to
leaderboard.
number 4. You're on the scoreboard that we can see. Congratulations. Number
Did we
20.
cover what people can actually win?
Not counting the
Bragging
OX at the
rights.
beginning, how many leading zeros does this deposit contract address have? Is it 6, 7, 8, or 9? So how many zeros are at the beginning of the deposit contract address?
Anyone here ever mined themselves a vanity address? Phil has. Frederick has.
There's 8 of them.
Okay, most people knew again.
Yeah.
See, that's what I'm saying. We ask these hard questions, and most people know the answer.
Yeah. Or they just clicked the button and they got it right. Just by chance.
Maybe.
Well, they're
maybe.
really
Like
fast at
me
Googling.
when it comes to a lot of this stuff. You just click the button and hope it's right.
Ooh,
Even higher
right.
up.
Belope. Is Belope here? They're online?
Maybe they're
They
on the
might be
stream.
online.
Okay.
And if you are, good job. You're on top. All right, next question, y'all. Which of these is an impossible state for an epoch? Is it not justified, not finalized, justified, not finalized, not justified and finalized, or justified and finalized? Which one of these is an impossible state for an epoch?
You should know
Pretty
this,
much
Buddha.
everybody knows this one.
Yeah, they know that one.
Yeah, there's no way it's going to go through if it's not justified, so.
Good work, everybody.
And Anon,
Little
number
bit of a
2,
shake-up.
climbing up. Congrats, Charles. You're making a comeback. 3 in a row. Good job.
We're not going to ask whether Anon is here because they're not going to tell us.
Yeah, because they're anonymous, right? How many beacon chain epochs are there in one day? Is it 164, 225, 420, or 332?
Admittedly, this is a question where I would wonder why you know this.
Yeah.
Yep, it's
Okay. Yeah, and
225.
again, most people got it.
Yep, 225.
Good work, good work.
It's 5 every time. Oh no, Anon, you went all the way down to number 5. Tragic. Next question, y'all. When will the merge happen? Is it when Vitalik says soon, trademark,
You guys better
June
not get this wrong.
2022, or never?
This better be
Imagine if it-
100%.
Yeah.
That's a tricky one.
Of course, it's soon, trademark. We don't necessarily know when. Hopefully, it's not that never. That would be truly tragic if it was never, right?
Might depend on the uptime of the master node in Zook.
Wackaro, you have like showed up on here. You're just moving on up. Hopefully, I said your name right.
It's all the research for the EF website he's been doing, right?
Which of these is not an Ethereum smart contract programming language? Is it Scythe, Bamboo, LLL, or Flint? Again, which of these is not an Ethereum smart contract programming language? Ooh.
Wow, okay, that one really...
Ooh, any programmers? Well, from that, it doesn't seem like it. I'm just kidding.
Did any of the top
Ooh,
5
tough
get it? None of the top
round.
5 got it.
Tough round. Apparently not. Moving on. What percentage of Ethereum hash rate is currently participating in Flashbot's auctions? Is it 25%, 86%, 98%, or 56%? This is definitely one you just tap on one and hope it's right.
You can just work this out for yourself. Just think about what's reasonable. There we go. Most people got it. Nice. Yeah.
86%.
Of course.
Yep, wow, that's pretty 50-50 on 25 and 86. Either you took it low or you took it high, right? One or the other. Ooh, Anon all the way back up to number 2. Domino, or Demo, answer streak of 5. Good job. What did Vitalik propose on April 1st, 2018? Was it a hard cap on the ETH supply, a new proof-of-stake mechanism? Did he propose a block or EIP 1344? Again, what did Vitalik propose on April 1st, 2018? Yep.
Nice.
It was the hard cap.
It was the hard cap.
The date is significant.
Yeah, I know, the date's interesting.
April Fool's Day.
Five-day-old burrito? Who is that?
I have seen 5-day-old burrito on the Rocket Pool Discord, so I did ask them what that tastes like, and they said they don't.
It's probably not very good,
You do not
huh?
want to know. It's
I
not
would
a good
doubt
time.
it's tasty.
It is not a good time.
Yeah, but congrats on your 4th streak. All right, next question. Only 6 more, I guess, technically. The primary reason we are all here today is because this World of Warcraft spell was nerfed. Was it corruption, siphon life tap, or seed of corruption? Any WoW nerds in here as well? Any?
I feel like
Any?
50% of the room knows the answer and 50% is very confused.
Yeah.
They're like, World of Warcraft, I've heard of that.
How'd we do?
Ooh.
Okay. Seed of corruption tricked a few people, but yeah, siphon life.
Siphon life. It got nerfed and he's like, done with this. I'm going to change the world now.
That's
Forget
right.
it.
When you take the video game away from Vitalik, he starts doing math and economics and
Yeah,
deep blockchain things.
Yeah, pretty much for him, instead of trying to like mathematically decide what's the most efficient ability to use, screw it, I'm going to do ETH instead. All right. 1 ETH equals how many Gwei? Is it a million, 10 million, 100 million, or a billion?
I was even nice and put the commas in there to make it easier to read. I thought about not doing that.
Oh, man.
I thought that would have been mean.
That would have been mean.
Yeah.
Not as mean as that other question, but it would have been mean.
Is there anybody that's actually done that?
Nice.
I hope not.
I hope
that
not.
is a lot of Gwei to spend on one transaction. Pretty good, pretty good. Nearly to the end. Which of these events happened most recently? So based on this list, is it the Kiln testnet genesis, Ape token launch, POAP announces a 10 million raise, or ETH at $2,159? Again, based on what your choices are, which one is the most recent?
Who can keep the sequence of crypto events straight?
In order, right? Yeah. Whoever can keep it in order.
Wow, most can.
Yeah,
All right,
it was apes.
Impressive. Ape token, that launched what, was that like 2 years ago? Feels like it.
Right? It's like 2 years in crypto time.
Yeah.
3
Top
players
5
hit
not
a 3
fooled.
Oh. 3 more. What was the earliest name for what's today MakerDAO's DAI token? Is it DAI, Psi, eDollar, or Xiao? Is it
This one's for the OGs.
Yeah, this is OG. Again, what was the earliest name for what is today MakerDAO's DAI token?
Ooh, only one.
Wow.
Frederick knew. Hey, there he is.
Wow.
Okay.
Tough round.
Oh.
Wow.
Now we know who Anon is.
We know who Anon is.
If you want to stay Anon, you can't celebrate when you're the only one that gets it right.
That's right.
Way to out yourself, man. You just KYC'd
Doxed.
yourself.
Self-doxed.
All right, second to last. What does ERC stand for? Is it Ethereum Foundation Reviewed Code, easily replicated contract, Ethereum request for comment, or Ethereum request for collaboration. You see it at like the beginning of every token. Come on, we have to know what it means, right? Come on.
I'm really proud of my fake
They're pretty good.
acronyms.
Of course, this Ethereum request comment. Request for comment, rather. Oh, sorry, I kind of took it away. I didn't even see how many people answered that right.
Butter, what happened?
Okay.
You stopped playing.
It looks like B. Lope has first place locked up. The last question's a fun one.
Yep. Last question. What is the best planet to buy 1 ounce of gold on? Is it Jupiter, Mercury, Venus, or Uranus? And yes, that's how you pronounce it.
It's not as hard as it sounds.
And we'll tell you the reason why.
Do tell me the reason why. I have no idea where this is going.
Yep. So it's the planet closest to the sun. It's comprised of which 2 elements, like all over the surface? It's gold and what again? I forget.
I don't know. It has the least amount of gravity, so you'd get 1 ounce of gold on Mercury would be more than 1 ounce of gold on Jupiter.
Oh, I thought it's because like the surface is literally a bunch of gold.
Oh, okay. Well,
Or did you just luck out on that?
yeah. Well, it was totally on purpose. Okay,
Wow,
let's see.
I thought you had science behind this, man. Come on. Well, I guess you kind of did. Who's on the podium? Who got third? Buddha.
Buddha.
Not first.
Bad,
Sorry,
not
man.
bad.
Anon.
Number 1, 23 out of 32. B. Lope,
32.
who is on the live stream. Congratulations, B. Lope.
Congratulations.
Congrats. Did y'all have fun?
Yeah.
Did y'all learn anything new? I think that's the most important part, right? Because here at ETHStaker, we're all about being welcoming first and knowledgeable second. Did y'all learn anything from our quiz today? Yeah.
Glad
Thank
to
you,
hear it.
everybody. We really appreciate you coming to our quiz show. Is there anything that our panel here wants to say?
No, thank you for playing.
All right,
As
everybody.
always. The joy of competing is the real prize because we don't have any prizes.
The prize is flexing on your friends.
Yes.
So,
Bragging
like,
rights.
these people are flexing. But all right, everybody, I hope you enjoy the rest of the event. Of course, we're going to have our next talk in here at 3 o'clock, I believe. Yes, all right, great. So, next talk at 3 o'clock. Be here or be square. And, of course, we have a hackathon that's going on day 3. If you have any kind of ideas that you can develop, then you want to go ahead and sign up for that. There's 10,000 USDC up for grabs. First place is 5,000. Second place is 3,000. And third place is 2,000, if I'm not mistaken. Again, you just need to have something that can be a demonstrable feature. And it needs to be staking related. But all right, everybody. Hope you have a great rest of your conference. Take care.
right. Thank you for coming back. Next up, we're going to have Obol talk about distributed validator technology. It's going to be Oshin, I think I got that right, and Colin. So please join me in welcoming them.
Hello. Hey, everybody. Thank you for joining us. I'm Colin. This is Oshin. We're the co-founders of Obol Labs, currently building the Obol network. Today, we're going to walk everyone through what we've been up to, past, present, and future, and what is to come. So what is Obol? Obol's a couple different things. Technology-wise, it's a protocol, and human-wise, it's an ecosystem. Both of these things are working together to foster the adoption of trust-minimized staking. Most staking today, if you use a provider, is done in a highly trusted manner. You are trusting an individual entity to manage the rewards and performance of your assets. We believe the next chapter is moving into a much more trust-minimized infrastructure setup for these things. We are utilizing DVT as a primitive to enable these things, and we'll get more into what that means. Let's talk about some math. What is going on? Why are we doing this? What you can see here is a chart of, this is a chart of all the Ether that's been staked since Genesis has started. So as we can see, it's progressively and continually increasing over time. We started this mission way at the end of this, before January 2021. And for us, we had realized that at that point, there was about 5 or 6% of supply in the network, and it was just continually growing and growing and growing. That's great, more security in the network, more people are staking, Ethereum continues to exude its dominance, it decentralizes itself. However, we were fortunate enough to be at a technical layer of these products at large companies in the space, and we were able to see that the key setup of this isn't really resilient. And it's not any one individual's fault, it's just an evolution of the technology that needs to happen. So today, it's $35 billion that's staked in the Beacon chain in entirety. Tomorrow, this will be in the hundreds of billions of dollars. And unless infrastructure primitives improve and advance at the validator key level, Ethereum will have faults. Ethereum won't continue to finalize. And solving these problems for us is what we consider to be the most important thing for the consensus layer. Where does this sit in the stack? So let's kind of intro the technical problems. So what you can see here is essentially how the industry is compiled today and how Ether flows into the chain, essentially. You have a collection of retail people who stake through a variety of different means. Some are at home, some are using liquid staking solutions, some are using providers. People use a variety of different things. The next layer is kind of exchanges, institutions, and custodians. This is where most of the volume in the chain and concentration in the chain comes from as well. What you have sitting underneath both of these products are a few infrastructure providers. And in different capacities. Many infrastructure providers have their own setups. They have setups for other products. They have a trusted setup. They have a pooling setup. They have a variety of different things, but really it's between, call it 10 and 12 major entities that are running the majority of stake. All of them are on this bed of what can be best thought of as a single instance configuration, which means that each of these providers generally have their own keys. And we'll get into how we solve that problem and what that means. To quickly walk through everyone, how did we get here? And what are some of the stuff that we've worked on? Oshin and myself have historically, we worked at Consensus for a very long time, and then post-Consensus had different paths, but we have been working on ETH2 in a variety of different topics since it was announced as Serenity in 2018. Both of us have spent time on economics. Both of us have spent time on preaching and spreading the good word about centralization and what could come of it. To kind of talk on the most important points here, two things to build on this are the effort of trustless validation, which is where DVT came from, was something that started in 2019, which I began participating in as an enabler to build teams, build dev teams, get a spec, get it audited, convince the large providers to help build this in a decentralized manner. And since then, we've kind of, at that point in time, we decided to pursue this full time. And these are a variety of the things that we had worked on in the past that are tied to it. Essentially, ETH staking has been our lives the past 3 years. And this is where we've decided to double down as we can add the most value for the chain at this layer.
Sweet. So now we're going to chat a bit more about where Obol is currently, and we're going to dig into the tech side of things, because fortunately this is basically the most informed crowd I'm ever going to present this in front of. So I'm capitalizing on that, if I'm honest. So the first thing we're going to do is, so the Obol network enables Ethereum to create, test, coordinate, and run distributed validators. So before we go too much into the Obol network, we'll start with what are distributed validators. So as we mentioned, for more or less all of the stake in the network so far, the private keys sit on one validator client somewhere. And the biggest problem is computers fail. So when that computer invariably dies, what are your options? Are you going to spin up a backup and play the game of getting slashed? Are you going to sit and wait? Neither of these are ideal. Both of them kind of have risks and economic penalties, and we want to fix this. So what distributed validator technology is at its core is kind of a Web 2 technology. It's a highly available software deployment. It's one piece of software running across many distributed nodes. And the key enabler for this is the distributed validator middleware client called Charon. And Charon has basically two duties. It needs to come to consensus with its other partner nodes on what should be signed. All of its connected validator clients will sign what they've chosen, and then it gossips them to each other. And once 3 of 4 partial signatures are received, it can construct the group signature and can send it onto the network, which will be validated by the rest of the Ethereum network. And what's special about this is it's the first time you can have a fault-tolerant validator, meaning one validator that stays online even though a piece of it goes down. And this is all well and good. This is a Web 2 technology, but we want to take it a bit further. If we built this technology and, just one of the major infrastructure providers ran it in 4 different availability zones of their data center, great, but that's, not really the end goal here. What we really want to do is we want to have groups of operators all running a piece of this single validator. All of them having a piece of the private key, but not all of it. This is what we call multi-operator validation. And the idea behind it, and our kind of core ethos is, if we can get most of ETH validation into the hands of groups and communities rather than single entities, I think it'll be orders of magnitude more difficult for Ethereum to be compromised and its credible neutrality to be compromised in future. So that's kind of what we're here with Obol doing. We're building distributed validator technology, but the real goal is using that technology to put validation into the hands of groups, not single entities. So Colin might introduce the next.
Yeah, so I'll walk everyone through the ecosystem. Super technical topic. It's a primitive, it's abstract, it's very early days. So it's been an interesting test for us to organize this effort, divide it into pillars and ecosystems, and then enable people to come and participate in it. So today, Obol is best divided into 4 core pieces. We have the DV Launchpad, which will walk everyone through. We have Charon, our middleware client. We have Obol Managers, which is Solidity that enables you to do unique things with your validators. And we have Obol Testnets as kind of the bedding ground of people to test their deployments before heading on to the Ethereum mainnet. So what does this look like? This has been a very interesting battle, honestly. We're fortunate enough as a project to have a lot of people who care and a lot of people who are interested to help us out. So this is kind of the map of the ecosystem, and this is how we're organizing ourselves. We primarily use working groups to get people together around different topics. And we use the proto community on the upper right as one of our primary filtering mechanisms. So everyone who wants to participate or cares or would like to add value to the network, going through the proto community is the main spot. And then we essentially activate individuals with different skill sets. And as a core team, we manage them. So today, these individuals in circles are activated companies with certain individuals inside of them that are participating and helping us. And these other circles here are kind of our working groups as they develop and we add more people inside of it. Today, the proto community, we've opened it up like over the past, I think 6 weeks after ETH Denver was the first time that we decided that, you know, there's just a lot of people in the Discord, there's a lot of people knocking on the door, we should organize this a bit better. Today the proto community is nearly 1,000 individuals and entities. Quite a lot, honestly, are here to work, and it's not a win token environment. So this is the ecosystem. This is an application that we use called Obol. It's quite cool. We'll provide a link to everyone afterwards where you can have this public link and you can continually check on who's in our ecosystem, what are we working on, how is the organism evolving. Because ultimately, as you can see, like, yes, there's a core team for Obol, but it's a huge community effort at this point.
Sweet. So now we'll dig into some of the 4 elements of the ecosystem that Colin touched on earlier. So as we mentioned, the kind of core software in this situation is Charon, our middleware client. I'm delighted to say that this is the first time we're announcing Charon is now open source. So if you really want to get your hands dirty and grab some super alpha software, it's public for you to have a go with. God bless you if you try. But over the next while, I'll tell you more about how we intend to roll it out. But as I mentioned, the main kind of 0 to 1 innovation with Charon is it allows you to have a fault-tolerant validator. However, we talked about, to take a step back, Charon sits between a beacon client and a validator client, and it intercepts the API. So our goal is not to, accidentally centralize stake when we are planning to decentralize it. So very intentionally, Charon does not control your keys. It basically just facilitates your existing validators by spoofing what public key that they think they're working on behalf of. They don't really, the validator client doesn't know it's part of a distributed validator. What's nice about being a middleware is it basically allows lots of configurability. You can run with most of the consensus clients and most of the validator clients to date. The 2 that are still a work in progress is Nimbus are in the process of separating their validator client from their consensus client, and Prism use gRPC rather than HTTP APIs at the moment. But the intention is that all consensus clients and all validator clients will be supported. So we touched on the fact that, fault-tolerant validators are great, but we want validators that groups of people run. And one of the hard parts about this is what's the story with the keys? So if you had one central entity create the keys and distribute them to everyone, you're kind of dead in the water already. You've kind of cut your knees off before you've gotten started. So instead, what you need to do is what's called a distributed key generation ceremony. And this is the idea that the group of people that will run the nodes all come together and they all take part in generating the keys. And at the end of the ceremony, everyone has their piece of the key, but the full key never existed in one place with any person or any customer. It just was generated during this protocol. And to do this is pretty non-trivial, if I'm honest. We've been working on this for quite a long time, and we've gone through many different iterations of the UX of this, because doing it in theory is fine. When you try and actually kind of user test this, it becomes tricky. Yesterday we were talking on the UX conference about the UX of this, so I won't spend too much time on it, but some of the kind of challenges are most DKGs assume that there's a concept of identity, being a public-private key pair. Fortunately, with ETH staking, we can already rely on the Ethereum public-private keys as a means of identity. So that's step 1. But almost all of the tooling for signing an identity starts in the browser. So then the next question is, should you generate keys in a browser? Maybe. Instead, it's generally better if you can do this DKG as close to where the keys are going to live full term. So we actually split this process out into 2 steps. And the first step is we've built a website called the DV Launchpad. And this is basically a modern variant of the existing ETH2 Launchpad, which some of our team were quite involved with making. And the idea is that it is the same objective. It wants you to come on, learn about distributed validators, get your cluster set up, walk through the creation. One person, decides on the config. They say, this is how many validators we're going to create. This is the Ethereum withdrawal address. Here are the participants. They set it up, and then everybody else comes along, sees the configuration, and if they approve, they sign the hash of it, and they submit their Charon nodes ENR, which is its identity. There's quite a lot in this, and I'm quite happy to chat afterwards about it, but some of the kind of major UX versus decentralization trade-offs we had were relating to things like how much, public infrastructure should you run to, improve the UX, but without, massively hurting the decentralization. So, our boot node's okay, our, centralized data availability layer is okay, our relays to help you talk to nodes behind NAT gateways okay. It's all a kind of a trade-off space, and it's an interesting piece to be working on. So once you have your keys made and your Karen clients are set up, the next question is how do we represent these on chain? Because invariably they do. So we as Obol are developing a suite of smart contracts that will be relatively unopinionated and will be kind of free for people to build off of. We intentionally are trying to stay at like a protocol layer, and we're not, an end-to-end use case. We're building kind of public good technology here. So the Obol managers focus on things like how do you tokenize these? Should they be fungible? Should they be non-fungible? Should you pool risk across clusters? Should risk be isolated? What does governance mean for a group running a validator together? Do you need to provably verify DKG and solidity? Maybe, depending on your use case and your trust model. And then one of the interesting ones is, can we do withdrawal address initiated exits, which a lot of people in the space are very keen for, because right now operators, dictate exits, which is interesting, I guess. So the next thing I want to talk about is testnets. So this software is complex, it is high value, and it has high trust. We are effectively going to people and saying, you should man in the middle your validator client with $1 billion on it, and it's a good idea, I promise. That doesn't happen for free and doesn't happen overnight. And we've a long plan in terms of how we kind of gradually improve the testing of this, and how we gradually step this up from kind of a girly testnet to a Gnosis testnet to a mainnet type of thing. So at the moment, we've recently open sourced. We're in the kind of like DevNet phase. We're just kind of getting the tutorials, getting all the client support, getting the real like first pass done. The plan is hopefully in about a month or two, in early summer, we will announce the first public testnet. This is where, if you just want to, follow a tutorial and get involved, that's the point where we hope that it'll be like kind of the right bang for your buck or return on investment. We will run that testnet for a few weeks, gather some performance data, and then we're going to blow it up. We're going to turn it into a TACnet. We're going to distribute, tools for DOSing it effectively. We'll do a bug bounty program with Immunify, and we'll end up probably with an extremely long list of things to fix. We will then go away for a while, get on the fixing train, and the intention is to show up for a public testnet 2, which we would run on Gnosis chain, the incentivized testnet. So at that point, right now a validator costs about $400, so there is real skin in the game, and you can't just kind of sign up and disappear and never actually run your validator, or you shouldn't. Same thing again, this time there will be money at stake, so you need to get this right. We'll run it for 3 to 4 weeks, get the performance data we need, and this time, rather than like a generalized attack net, we will turn it into a red team, blue team network, meaning 1 in every 4 is on Team Red, and their job is to disrupt their validator. And if they do disrupt their validator, they'll get a bonus. And Blue Team's job is to defend the validator and keep it online, despite a Byzantine operator. And if they do, they get the bonus. So that is roughly our plans in terms of testnets. And then, going forward, as we kind of go to mainnet, Colin will talk a bit about how will the economics of this work out.
Economics are quite interesting in this category. Certainly progressive and gradual economics is the right path. However, Obol and the network itself is not like a client. So some type of economic viability must exist at the beginning. So what we're going to get started with is something that a lot of people, Optimism has led and some other projects have done recently, and this is this concept of retroactive public good funding. For the entirety of V1, however long that runs until we migrate to V2, all of the funds that are collected by Obol for its services will be distributed to different projects and streamed in the space. The Obol community will do that as a unit. We'll be public about it. We'll discuss and we'll choose what is best. And at that point, this may be the best time to introduce a token for us. Right now, this is a tokenless project. Including a token inside of this is just unnecessary today. It's more of a tomorrow thing. So this is how we're going to bootstrap economics. This is how we will introduce a token. This is where elements of governance will be introduced. Governance is an interesting topic for this as well. And yeah, so it's gradual, but we'll get started with a MVP of economics and one that gives back to the community and helps other small projects over time.
So we referred there to a V2, and we haven't really described it at all yet. So what do we mean by V2? So this first version that we've outlined to you is what we call like a trusted distributed validator, meaning there's no internal rewards and penalties. You have to know and trust the people you're running a validator with. If someone's offline, you hit them up on Telegram, you hit them up on Discord, you sue them for all it matters, but the actual client itself doesn't manage to, doesn't do any sort of rewards and penalties. We decided this because we wanted to keep things simple. We wanted to build, distributed validators, and we wanted to fix a problem first and foremost. However, that fixes the problem for the larger entities that are able to, make an agreement, or people with, a lot of friends in the community that can run a trusted validator with them. There's a long tail of, home validators or people that want to get involved that don't have the network to run a validator together. And we want to, service everyone. We would like, pretty much everyone to be able to take part in group clusters, because that's how you get the most resilient validators. So version 2 of Obol will effectively have what's called attributable threshold signing, meaning you can tell who did the signing and who didn't. And this is complex to do non-interactively. It's not too bad if you can handle, more of over and back games, but when you're trying to, get all of this signed and out in 4 seconds, that was complexity that we didn't want to bring in, particularly because with an open source client, we could make this kind of economic game, but someone would just fork the client and tweak the results and start to misbehave. So this version 2, if you're interested, it's a working group stream, and it involves a lot of non-interactive proofs, which is zero knowledge proofs, and it's the first time bringing crypto economics into the protocol. So if you're interested in getting involved, we'll be delighted to talk to you about it. But that's the future of Obol and the long tail effectively of home stakers. That's pretty much everything for our talk today. If you'd like to find us on the internet, on Twitter, we're at Obol Network. I'd like you to check out the docs. Karen's open source if you're feeling optimistic. And the website is also there. And I would now like to show you our last cool graphic of our multi-client cluster and ask if people have any questions. Thank you very much.
Thanks, everyone. Do we have a formal way of questioning? Does anyone have questions? It's quite bright up here. Sorry, can't see anything.
And just a question about when a group of people want to stake with your solution, but you didn't mention anything like these funds, this 32 ETH. Is it group of people give it to one person, and how does it work?
Yeah, fantastic question. So we're experimenting and user testing a variety of ways to activate the validator, and there's trade-offs, particularly around funds getting lost. So the real snag effectively is when you're constructing a deposit data for a validator, you have to specify how much ETH you're sending. So for the most part, everyone just says 32 ETH and they activate it and things don't go too wrong. If you want 4 people to contribute 4 ETH, 4 ETH, 8 ETH, whatever, each of them have slightly different deposit datas. And if they kind of make an adjustment and they decide to contribute a little extra or a little too less, they've made an invalid deposit and their funds are gone. So we're effectively making this trade-off of, do we want to go super down this path and, play the game of worrying that people might lose funds? Or instead, what are some of the kind of things we'll kind of test the waters with first? So we're leaning towards, as we talked about, like testnet and Gnosis chain first. Our plan is to lean closer to like multi-sigs and let people activate them as a group, or even like in the testnets, most likely you will just submit a deposit data and we will activate the validator. But yes, the plan is to address this. But the one other thing I will say is only a subset of validators are a situation where an operator is putting up the capital. Like for the vast majority of stake at the moment, the operator isn't putting up the capital. So we're also worrying about, you know, how do you give your deposit data file to somebody else to activate, and how do they know it's actually, you know, a distributed validator? They can look at the withdrawal credentials and they can see where that goes. They can see, you know, this is a splitter contract, this is, you know, the DAO, that's fine. But the DKG, that comes with a proof. It's a PVSS, it's a zero knowledge proof of a fair DKG. We're chatting with, I won't name the names, but they're in the audience, how to verify these DKGs on chain in a gas efficient manner. So you can hand deposit data to somebody else and they can reliably see the withdrawal address and they can see the DKG and they're like, cool, this is probably what I'm getting, and they will activate it. So yes, we're aware that, you know, people want to kind of like all pitch in and we will facilitate that. But we need to be careful. Basically, we don't want to lose people's money. Like if you kind of your entire stack is 3 or 4 ETH, you add in an extra half ETH, and now you've lost the entirety of it. We didn't want to. We didn't go down that route in our launchpad for V1 because I guess the risks outweighed the rewards a bit. But yeah, it's a great question. We did user testing, and all 5 people came back with the exact same feedback. So yeah.
All right. Hey, super interesting. Thanks for the talk. I'm curious about the public goods funding aspect. Can you go into details? Maybe like where are these funds coming from? Why aren't they going to the validators, the operators? Yeah.
Yeah, so there will be some type of community-decided fee. We imagine Obol as like, well, if you look at how other people, I guess, fee sweep and staking products, you know, if we take a look at how Lido does it, it's 10% divided in half and then funneled in different directions. As Obol is something that's meant to be used by everyone, that extraction, if you will need to be drastically lower than like what some of the products are in the space today. We have no comps for this, you know, for what we do actually. So it'll be a community-based decision. We assume it'll be in the 1% range as kind of this guiding principle to get started with. And then it will take 1% and it'll go into the DAO. And then as a community, we'll have to make a decision as to which are the best projects to support for that. And then we'll also need to figure out the intervals of how often funds are distributed, right, and the coordination around all that. It's definitely super early days on the economic design, but it's really going to be needed to be decided by the whole community, which will take some time to decide as well. Yeah, so we're in the beginning innings.
Anybody else with some questions?
I was just wondering about the liquidity aspects. Will it just run in line with the normal validator, with the Ethereum system, or will there be a liquidity aspect as well?
So Obol probably will not be the one providing like liquidity or fungibility and stuff. We are building this, you know, complex software to share stake. And the two of us are from kind of Codify's like tokenization service, and we know that you should not be sharing the risk and sharing the like financial side. It's basically how you get in a lot of trouble. So no, we would be basically sitting on a lower level being like, here are these validators. If, you know, the existing, you know, staked ETH and like liquid Ether solutions want to use us, that would be the approach to fungibility. We will probably not spread risk across clusters because we're taking enough, you know, spreading of risk on ourselves that would be maybe sued for that.
I'll give you the product perspective there. So today, all of the staking products are full stack products. All the liquid staking tokens, they do the whole stack, all the way from the ground, all the way up to integrations, governance, liquidity, all of these things. Over time, these products, as we've seen the largest ones in the space, like they will decentralize, and then different pieces of that technology stack will be componentized or modularized or whatever the word that you want to use for it is. That's also in line with how Ethereum is designed. Like DVT, for example, is a primitive that exists in Definity and other ETH killers natively in protocol, right? The decision has been made for this to sit on top and let markets play out around the primitive. So the whole ecosystem from the ground up is designed for that. We view ourselves inside of a full stack staking application as the lowest layer. You'll make your decision about clients, and then you'll make your decision about middleware and how you do your keys. So we like to, our goal is to be invisible. You know, if you're using liquid staking pools, you shouldn't even know that you're interacting with us. You should just know that the pool itself is much more stable and healthier for the network itself. Yeah, that's the product perspective as to why we call it the top and bottom half. I call the top half deposit interface, liquidity, governance, integrations, and then the bottom half is keys, basically, and validator coordination. Validator coordination is extremely difficult, and it needs to be someone else's job, which is also part of the reason why Obol was started. We were looking at all these different products and speaking to people, fortunate enough to have worked with all the validators for multiple years, and everyone kind of looked and said, we can't do this forever. Like, there needs to be software and crypto economics and cryptography that actually takes care of this coordination and punishment mechanism. However, the scope of getting that done is quite vast. So yeah, we sit at the bottom half of the equation.
Any last questions, guys? Okay. Thank you very much for listening to us. This was very helpful. We'll be hanging around for the next few minutes if anyone wants to come up and ask some questions, not on a mic. Thank you. Look.
Hello, hello, hello. Thank you. Next up, we will have the, I believe it's a dual core dev, Adrian from Consensus, talking about checkpoint sync, how you get synchronized in minutes or seconds. Thank you. Please welcome him.
Thank you. I told him not to mention the dual core dev thing. It sounds awful. Yeah, so I'm here. We're going to talk about checkpoint sync and weak subjectivity today and take you through some of that. So, yeah, my unique claim to fame is I have worked on both Teku and Besu, so I've seen the execution and the consensus layer side. My real focus at the moment is on Teku and has been for the past 3 years or so. I'm one of the core devs, helping to bring that from research through to the Beacon Chain mainnet launch and then onto the merge and beyond. So, checkpoint sync. We're going to actually explain checkpoint sync in about 2 slides. It's really quite a simple concept, and the first slide actually doesn't talk about checkpoint sync. When we sync from Genesis, the Beacon Chain is the same as, in many ways, as the execution layer in terms of applying blocks and moving through, but a little bit unique in that the state is really small. It's about 50 megabytes. You can get it in a single file. It's not a big thing you have to sync. So as we go through, it's a much clearer view that we start from a given state. So for Genesis sync, we start with the Genesis state at slot 0. We apply the block 1, we get a state at slot 1. And we can keep doing that, either processing an empty slot or a block, all the way through the chain until we reach the head. And it's that simple. Each time, we're applying one block, getting a state. And it's clear enough that you can even do this with command line transition tools. All the clients actually have some of our debug tools so that we can literally take just a state as a file and a block as a file, and it will do the state transition for you. So you can check why we had a consensus failure and things like that. So checkpoint sync has exactly the same idea, but just realizes, hey, the only thing we actually need to apply a block is the previous state. So we don't need to start from Genesis. We can start from, effectively, any state from somewhere along the chain. And so we start from slot X, whatever that might be. We want it to be finalized. That is the one key requirement, because we don't have any states before it. We can't reorg anything deeper than that. So we're not changing from there. Same as fast sync or snap sync in the execution layer. You can't go back beyond that without kind of resyncing it. And then we apply blocks on top of that. That's the entire point of checkpoint sync. It's all it is just don't start from the beginning, start somewhere close to the end, and then you'll be done sooner. So I don't trust the Wi-Fi here. It's failed me at many venues. So if I'm lucky, we will have a video that I will talk you through. Checkpoint sync is actually pretty simple to run. I'm going to sync Teku on mainnet, the full mainnet beacon chain. It's pretty small, so I don't know how well you'll see it. Hopefully it loads. I'm going to use Infura as the source for my state, and we'll talk a bit about the good and bad of that in the future. And you can see I've just passed it as a URL. So the first thing it does is it goes to Infura, and this little pause is while it downloads that 50 megabyte state file, just over HTTP. Once it's done that, then it will start searching for peers. And this is actually probably the slowest part of it. And it's really nerve-wracking when you're trying to stand on stage and talk through this, especially in a live demo, because the peers seem to take forever. That's the phase we're in now, so we still haven't found peers. We're basically just sitting. We're not able to do anything. But the key thing to notice is our head slot there that's reported is 3.5 million already. And we're 83 slots from the head of the chain. We're that far along because that's where we started. We started with the latest finalized slot. And all we've got left to sync is the non-finalized part of the chain, which, when it's working normally, is about 2 to 3 epochs worth. Any moment now we'll find peers. Doesn't matter how many times I go through this same video, it still feels like forever. There we go. So we found some peers and we started pulling blocks. Our sync has started. We'll get some more updates. I think it goes a couple more. And this is now a normal sync process, right? We've started just like we've started the client. We're a tiny bit behind. We're going through. Our sync is now complete. Our node is now in sync. And at this point, it's as much as it feels awful, from here it feels like it's been forever. It's been under 2 minutes. And we've synced a beacon node fully to the point where validators, if they're attached to this node, would be able to attest and produce blocks and carry on. And we're starting to see these slot events come out, and we're tracking the chain head. The one final detail that goes on is in the background, we start to download the full chain of blocks that we'd skipped. That won't be something that we do forever, but right now there's still a lot of clients, or some clients don't have checkpoint sync at all, and it's coming soon. I heard yesterday, but it wasn't. So any moment now, the last major client should ship that. But it's still relatively common that people are syncing from Genesis, and we want to be able to support the network. So we download all those blocks and verify them in the background so that when other peers are requesting them from us, we can provide them. As time goes on, we'll do things like the portal network and other ways of sharing and keeping those blocks on record without every node having to store them, and disk space will shrink for nodes running consensus, which will be great. So, the big question with checkpoint sync, and it's been a real chicken and egg thing as we've developed it, is where do you get the state from? When you're syncing from Genesis, it's built into the client. So consensus nodes no longer go through the whole ETH1 chain processing deposits to see what the Genesis state was. They could if you wanted to verify it again. But it's an awful lot faster to just start with the Genesis state. And so all the clients actually just embed that. And that's great, but it doesn't work all that well for checkpoint sync because you want something very recent, and we only release clients every so often, and it's a real burden on devs to kind of keep shoving a new one into the release and putting it out. So you can get it from any other node using the standard REST API, and that's the curl for it. The REST API by default will return you a JSON, massive JSON blob of the whole state, but you can specifically request octet stream, and it will give it back as SSZ, which is what we need for checkpoint sync. That's great, but the whole point of this was we wanted to sync our node so it doesn't have a state for us yet. Like, if you're a solo staker, not a lot of point in where are you going to get this from? You need someone else. It could be your friend. If you know someone who's got a node synced, they can put that state on a USB disk or email it to you or whatever it is, and that works great. But the other place, and the most common place, is Infura. And that works because Infura provide access to the standard REST API, including this ability to request a state. It's great, but the big question is now trust. Because I mentioned that we won't reorg anything past that checkpoint state that you start with. We won't ever consider any chain that doesn't have that state in it. It's a trusted starting point, which is kind of the point. And that's where weak subjectivity comes in, and we'll talk about that. But that starting point is really important. We want to trust the node we get this state from. When we're doing a Genesis sync, we're getting it from our client. They're all experts. We trust our client developers. And you kind of have to, right? They wrote the rules. If you're syncing from Genesis and thinking, yeah, I'm validating the chain, and your client is just saying, yeah, that's a good block to everything, which you could easily do if you haven't audited the code, it's not great. So we're trusting a bunch of experts that we kind of have to put some trust in that the Genesis state they embedded in their client is right anyway. That works. Checkpoint state is a little bit more iffy. We're going to just send a HTTP request over the internet and hope it doesn't kill us, which sounds really bad. And you might wonder, why did we bother with this talk for me to tell you, look, all this wonderful shiny stuff, sync in 2 minutes, also might kill you. But the real catch is that checkpoint sync is actually the better option of the two. You put these two up and you'd think you'd always pick the expert, you'd always do the Genesis sync. But there's one nasty little detail called weak subjectivity. And it's why you can't trust the Genesis state. All right, you can trust the Genesis state, but it doesn't necessarily let you sync well. Now, visualizing a complex chain is difficult. We're going to do it 2 ways. First, imagine that this is a block. All of these things, one block. Each box is a validator, and all our validators at Genesis are active. and they're doing their job. It's great. We've got a single chain. It's only Genesis, basically. A little later, one of our validators has exited and withdrawn their funds. Okay, today they can't actually withdraw their funds. They can exit, though. And it won't be too long before we have actual withdrawals. We know what's coming. Later still, a whole bunch of our Genesis validators, in fact, 2/3 of the Genesis validators have now exited and taken their funds out. Now, all through this, the chain keeps finalizing. That's really important to realize because we've still got all the active validators, the ones that haven't exited, are still agreeing on the chain. Things are going like normal. But we've got this bunch of validators that have taken their stake and left. And that's fine. We want you to be able to get your money back out, but they have nothing at stake anymore. You can't slash them. So today, in protocol, you can't slash them, but we could theoretically agree that they've misbehaved and do an irregular state transition to take their money. We probably won't, because it's an awful lot of coordination for something we know can be a problem. And once withdrawals are there, they will actually be able to take away their money, and there's nothing we can do to them. So if we look at this a second way, these are all our validators in a little block. So I've got 6 happy active validators on the same chain, and they're progressing along well. They keep going, and this is the top chain. So this is all we know about at the moment. Life is good. We see those couple of validators exit, then a couple more. Chain is finalizing. That's our finalized block at the end there, over that end. When we are following the chain as it happens, we will be guaranteed that we get to that point and that that's our finalized chain, and we won't consider anything else. But if we remember those validators that took their money back out, they might now, after this has happened, go back and mine a different chain, which only they have. So our still active validators, the top row, aren't on this chain. They're not attesting to it because they never saw it. It didn't even exist when these slots actually happened in real time. Right? These all just were created much later. And this looks like something you should be able to slash validators for. They've produced 2 conflicting blocks for the same slot and attested to 2 conflicting chains. But they've already taken their money out. There's nothing to slash. So if this had happened in real time, yep, we'd absolutely slash them. Perfect guarantees that's the security of our chain. But because it happened afterwards, we can't go back and retroactively slash them after they've withdrawn their funds. And that's the fundamental problem of the weak subjectivity issue, that there is a period of time where if you're offline long enough validators might have exited that they can then go back and create a different chain, and you don't know they've exited, so when you follow it. So let's look at that case. We're a node that comes along much later and is syncing the chain after this has all happened. The first chain we happen to see is this bottom chain, and it looks perfectly valid. In fact, it is perfectly valid. If you're starting at that second block, the third one, the first on the bottom row, that's a perfectly valid block. There's no reason you would ever suspect that you shouldn't import that. Right? If it had happened in real time like this, that would just be our chain. Totally fine. And so your node goes along and syncs and follows that chain, and it finalizes as it goes, gets to that bottom node, and is now finalized there. Then it finds a peer that gives us this other chain and rejects it because it's not descending from your finalized node, your finalized block. Right? So that top row is now actually the invalid blocks. They're valid each individual state transition, but because they don't descend from your finalized state, they are not valid, and you won't consider them. You will never reorg to them. That's obviously a problem because you've now been locked onto a bad chain, not the canonical chain. And that right there is the weak subjectivity problem that we have. So in this, we talk about the weak subjectivity period, which is how long you can be offline for before there's a risk that there's this second chain you would be fooled into following. And it's really important that when you start your sync, you're within that weak subjectivity period or have something else that will ensure you're actually getting onto the right chain. And once you're in that weak subjectivity period, you can follow the chain perfectly securely on your own. You don't need to trust anyone else. That's a really important detail. Right? I'm not saying that proof of stake doesn't work and you can't trust the chain, merely that you have to be relatively close to in sync with the chain within, I think it's about a month or two, depends on the number of validators there is. If you're relatively in sync, you can keep following the chain perfectly well. But this initial sync process and getting up to speed requires a point of trust on the chain. This isn't as theoretical as it might sound. So on mainnet, we know that not enough validators have exited yet. So there won't be a fake chain on mainnet. But there is a fake chain on Piedmont. The Nimbus team created a chain they call Insecura, which they deliberately started with about 12,000 validators from Piedmont, knowing it was going to shut down. And they ran a phony chain, created this fake chain with their 12,000 validators, and just waited for all the other validators to leak out through the inactivity penalties until their chain finalized as well. So there are two validly finalizing Piedmont chains, and when you're syncing, you have to be able to work out which one you should follow. So that URL has some instructions so that you can actually use checkpoint sync to pick the invalid chain and be guaranteed you're on the invalid chain, which is really convenient if you want to be on there. But similarly, shows how it works. Now, this particular case, 12,000 validators, you don't need that many. And the write-up did talk about how it's difficult with a small number, but for example, in the ssv test network quite some time back, I forgot to turn off a node, and it was running a validator, just one. And I forgot it for a few months, and I came back one day and I went, oh, the chain's finalizing. Wow, who's still running their nodes? Oh, just me. I just happened to have enough balance that even though I'm not producing blocks because I'm not getting scheduled to produce blocks very often, so I'm leaking pretty much the same rate as everyone else, and there's this huge long period of no blocks, I just had enough ETH in my balance that I stayed around longer than anyone else, and I owned ssv. That was fun. So you can do this from very small numbers, and I guess that's worth kind of coming back and thinking about as well. In this example, you might look and say, well, we saw this bottom chain, surely that's slashable now. We can slash them on the bottom chain at least. They actually control that chain, so they're going to censor any slashings. They're not going to include it. But similarly, you can do a lot of other things. Like this is a simple example, and you can exit all the validators you first used to finalize the chain while adding new ones which are under your control, and you're voting on what you see as the ETH1 state and deposits because you're the validator set, so they don't have to be real deposits by the time you own the chain. And you can kind of cycle these things through. So you can make it look like a pretty convincing chain without actually having a majority of the validators. You don't have to acquire 2/3 of them. But the more you get, kind of the easier it is. So now we kind of have this choice of we can sync from Genesis and hope we get the right chain, or we can start from a random state on the internet and hope it doesn't kill us. Either way, not really great, is it? So we want to start from a trusted point, but we want to verify what we're doing. And this is too often missed in what we're looking at and talking about with any type of sync, whether it's proof of work, whether it's Genesis sync of the consensus chain or checkpoint sync. People don't verify enough that they actually synced the chain they expected to, and look at the block they wound up at and check it against explorers. So start doing that. When you spin up a new node, there's a few ways you might verify it. If you're syncing from Genesis, don't really recommend it, but if you are, you can specify a weak subjectivity checkpoint. The idea of this is that it's a block and epoch number that is relatively stable. By convention, it's updates every 256 epochs or so. So it has a long lifespan, and it's guaranteed to be within the weak subjectivity period, but a reasonable way back. As you sync through that, your node will check that that block root is at that slot. And if it's not, your node will crash and tell you that you've synced the wrong chain. Sorry, try again. That's a bit of a problem because you've just spent 3 days syncing the beacon chain for it to tell you, got it wrong. You're secure, but you're really pissed off. So if we use checkpoint sync, we know that the starting point might be bad, and we want to verify that. So we could download a state. We could just get the state from one of our other nodes from a friend, something we really do trust, and that's fine. But we could also verify the actual state itself against something like Beacon Chain. Every state has its slot, and you can just go to any block explorer and look up what the block root was at that slot, look at what your state is, and see that, yeah, these are the same thing. Then you know that you have a state that was on the canonical chain. And particularly if you check it from a few different sources, you now have a high level of confidence that you're going to be starting on the right chain. And for either approach, you can do that same thing with the head block. Once you've synced your node, look at what it's telling you is the latest block and check that against some other sources. Phone a friend, check Infura, check Beacon Chain, check Beacon Scan, those kinds of things. And the more sources you check, the more trust you have in that. And because of the inclusion of hashes and the fact that a blockchain forms this full chain, if you're at the final head block, you know every other part of your chain is valid. Right? So you get that full verification of the whole process. Do one of those things. Right? Get out of the habit now, because a big part of this is getting into the habit of syncing the chain securely, rather than defaulting to Genesis because that's what clients do if you don't provide any options, because they've got no real choice. It's a bad habit. It won't kill you now on mainnet, but one day it might. So get into the habit, and it's a lot faster. It's better anyway. But make sure that habit of verifying is there as well. So there are some challenges, and we've been playing a bit of a game of chicken and egg with all of this. Because getting the state is kind of challenging, and it's a lot easier than it used to be. But as much as I love Infura, they're part of Consensus, trust them, it's like running my own nodes, it's great. But we don't want to centralize on them. We don't want that to be where everyone goes to get their state. And today it is, basically. The other option is that you ping me on Discord, and I've got a GitHub repository where I just stash states from testnets and things like that and give you URLs, because it was the easiest hosting I could find. That kind of is the guy by the highway that I wouldn't recommend, but we can share those states. But actually, we really want more infrastructure providers providing these states. And it's not hard. If you're running a block explorer, you already have a node. Any infrastructure provider that's providing information about the chain will have a consensus node, which already has the API to give them this state. And it's beautifully set up to provide that state and just set some HTTP headers to cache it for as long as you want. And your CDN will then take care of distribution. It's a really simple problem in terms of the distribution, and it works so nicely with HTTP. We just kind of have to convince people to start doing it. So I saw Buta around, but I'm going to shame him. When is this coming to Beacon Chain? When's it happening? We need to ask that of a whole bunch of providers and get more than just Infura being the source of these states. So that's one of the problems we have right now. The other thing is that the verification is still manual. You shouldn't really have to go and manually compare block hashes. It's not great, and most people don't do it. So we need to find better ways of automating that without necessarily having client developers decide where the trusted places are. And the other real problem is that the default is sync from Genesis. Why are our clients defaulting to something that we know is going to be insecure? Because the other option is to say, oh, can't sync. It's kind of an awful experience. So we need to kind of work that out, combination of experience, of education and changing clients. But the nice thing is, oh my gosh, it's fast, right? 2 minutes. And it works as a backup as well, remember. So instead of backing up your whole database, you call that API to get a state regularly. You know your node is going to be able to be back up and running in 2 minutes. You don't need to sync your whole Beacon Chain database anymore. It's more secure than Genesis. There are people that still disagree with me on that and still have the religion of syncing from Genesis, and I'm just stating it as a fact because syncing from Genesis is not a good approach. At best, you can find out that you got it wrong after the fact, before it does too much damage, but you've still wasted a lot of time. That's not secure. Stop doing it. But also realize checkpoint sync is not trust-free. You are choosing where you are going to trust to give you that starting state, and it's important to know. We talk a lot about trustlessness in blockchains, And it's very, very rare that we actually have trustlessness. In fact, I don't think I've ever seen a solution where there is no trust at all. What we do is we give people the ability to choose where they put their trust. And sometimes that is almost entirely in them, and that's almost trustless. But generally, there is a bunch of trust that somebody else audited that smart contract, and we trust them, or we trust the network of people around it. We're choosing where to put trust and distributing that trust, which is where our security improvements come from, more so than literally everything is trust-free. That kind of black and white is not really as accurate as people make out. And yeah, so the final thing, obviously, more support from infrastructure providers. Ask them about it, put pressure on them. Let's work as a community to solve some of these problems and make checkpoint sync a really common thing. Right. That's a bit whirlwind, but if people have any questions, I'd love to answer them for you. Yeah?
What about the execution layer?
Yeah. Those guys should get their act together and shrink their state or something. Yeah, look, it is hard. So the execution layer actually benefits from checkpoint sync post-merge in that the consensus layer is designed to be able to optimistically follow the head of the chain. And that lets it tell the execution layer, this is the block you're expecting, this is where you're going, which they otherwise wouldn't know. And that enables things like snap sync to work. So you still have that slow sync that you get today with a snap sync type thing, but checkpoint sync lets you actually continue to use snap sync after the merge, whereas otherwise you would find that you can at best snap sync to the merge block, and then the EL kind of has to get one block at a time from the consensus layer, which is a really slow way to sync, that step-by-step sync. So checkpoint sync comes into play there, but unfortunately it does mean that some of the benefits of 2 minutes to be completely in sync and validating won't play out. You'll be 2 minutes and you'll have the full beacon node there, but you still won't start validating until your execution layer has the world state fully downloaded, which still takes a reasonable amount of time. Bring on statelessness. Yeah.
Do boot nodes or when a client is connecting to a new partner handshake and try and figure out if they have a common checkpoint or anything?
Yes. Yeah, so it's not so much in the discovery part, but when you first connect to a peer, there is a status message, I think it is, in the P2P that is exchanged, and that includes the finalized epoch and root, which is why the checkpoint sync needs to be on a finalized boundary, because that becomes your finalized state when you first start up. So that matches if you do that, and it kind of is on the same chain. And yeah, you're right. If you're then if your initial state is from a different chain, a different fork, you will actually reject connecting to every peer because they look like they're on another chain, which makes it even easier for you to go off and follow the wrong chain.
Is this fast sync already implemented in Teku client? Did I understand correct?
Yeah, so checkpoint sync is supported by Teku, Lighthouse, Nimbus, Lodestar, and it's coming in the next Prism release, I believe. So Teku's had it for a fair while now, before you could get a state, really. It's been one of the things that we looked at optimizing sync speed and thought this is a bit of a waste of time. We can put in some optimizations for it that are purely to do with catching up on this old chain, or we can skip it all. And particularly prior to the mainnet launch, there was a lot of talk about how we really needed to get this bedded down. It was a major concern. And we've realized actually, the validator set doesn't turn over that fast. We actually had a lot more time than we gave ourselves credit for. But yeah, that's been something that's been around in Teku, and we thought it's been important, but also just so good for users. It's just so nice to use that it's been a priority for us. And I'm delighted to see the other clients have seen that working and had the infrastructure there now to support it, that it's become kind of the norm.
Would E2 Forkman be a good place to find checkpoint syncs? While you find finalized routes?
Probably would, actually, yeah. It's not designed for it right now, but yeah, it could quite easily add it because it's got that data from all the clients, yeah.
Is this Infura project, is it open source or is fully private? mentioned that maybe other providers can spin up their own Infura. So if it's open source, they could do it.
Yeah, so Infura isn't, and the source code for Infura probably is the easy part compared to the number of nodes and just the experience of running that kind of scale. But you don't need Infura. One of the advantages is you just need any node, and you can grab the state from that. So you don't need the full API. Different clients do different exactly what they need. Teku, we've taken it to the extreme that we literally just need the state. Most other clients want the block and the state together, but that's still really easy to get from any node and serve. So I think it is one of the things we want to do is push towards making it normal that you don't have to point to the standard REST API to get these things from, but just any URL. And then you can much more easily use CDNs and all kinds of HTTP caching to spread these states around without it being a burden on infrastructure providers. Awesome. Well, thank you all very much for your time. I hope it was useful. I apparently talked quickly, but I'm Australian. I do that. Thank you very much.
Concertzaal